All right, next function. Let's do another example. So here's my function g, and I want to compute the derivative g prime. And I'm going to start with the definition. So I'm going to begin by saying g prime of x is the limit as h goes to 0 of g of x plus h minus g of x all over h. And so this is the limit as h goes to 0 of, now this is going to get messy, but we're going to figure it out. So g of x plus h, everywhere you see an x in g, you plug in x plus h. And so I'm going to have 1 minus x plus h over 2 plus x plus h. That's g of x plus h minus 1 minus x. I need to get rid of that. There we go. 1 minus x over 2 plus x all over h. And so we'll go down here. Let's realize that to be able to simplify this, I'm going to need to combine the upstairs terms. I'm going to need to find a common denominator, which is going to be this denominator times this one. Excuse me. And so I'm going to have the limit as h goes to 0 of 1 minus x minus h all times 2 plus x, multiplying this side by 2 plus x. Then I'm going to have minus 1 minus x, because this negative applies to the whole thing here. So 1 minus x times, I need to get the other side, 2 plus x plus h. So I'm multiplying this denominator top and bottom here. And then I'm going to have everything over the common denominator of 2 plus x plus h times 2 plus x all over h. Oh yes, this is epic. So now, now, as if life wasn't bad enough, I need to FOIL all of these things out. And so here we go. Let's do it. So I'm going to get the limit as h goes to 0 of what? 2. You know what? I'm going to go, I'll go each one of these two like that. So 2 plus x minus 2x minus x squared minus 2h minus xh. Now, you could try to push the negative through as we FOIL. I'm going to leave it in a parenthesis and then FOIL this out. So I'm going to get, what, 2 plus x plus h. Then I'm going to get minus 2x minus x squared minus hx. And all this over 2 plus x plus h times 2 plus x, all this over h. And now if I was doing this by hand, I'd probably just erase these guys and push the sign through and change the sign everywhere. Since I have a fancy iPad, I'll just copy and paste. Of course you can't do this, but that's okay. And now we can, well, let's see, we can erase. So we're going to erase the parentheses, and then I want to push that negative through. So it's going to be minus 2x. It's going to be minus x minus h. So let's erase those pluses, make those negatives plus, plus, plus. And now we can begin looking for terms that cancel. So I'm going to use a green highlighter. So the 2 and the negative 2, those cancel. Let's see, the minus 2x and the plus 2x, those cancel. We could have combined them, but we're just canceling x and the minus x, those cancel. What else? Let's see, minus x squared and x squared, those cancel. Oh, this is great. How about the yellow? Minus x times h is the same as xh is the same as hx, and so those cancel. And so, holy moly, you can see that all that we're left with is this guy and this guy. And so this whole thing simplifies down to the limit as h goes to 0 of minus 3h over 2 plus x plus h times 2 plus x all over h. Think about that bottom h as h over 1, and then what you do is you flip and multiply. So you say 1 over h like this. That's the same thing. And moving this up here like that, 1 over h, we're going to cancel the h's. And so My next step is this is the limit as h goes to 0 of negative 3, let's make that line better, negative 3 over 2 plus x plus h, 2 plus x. And at this point, I realize, okay, I can let h go to 0, and I'm left with negative 3 over 2 plus x times 2 plus x, which is a 2 plus x squared. And so let's rewrite it at the bottom. G prime of x is negative 3 over 2 plus x squared. And I thought, again, you might like to see what the function and its derivative look like, because the derivative, right, is a function. This is a function. You can graph this function, and if you want to know the slope of the tangent line of the original function of this g of x, then you could just plug in the value that you're interested in. So if you want to know the slope of the tangent line of this function at x equals 10, you can just plug x equals 10 into this formula that we came up with. So let's switch to Mathematica, check out the graph, and then we'll go from there.
All right, so as before, we've got our top function is the original function. This is our g of x. And the bottom graph is a graph of g prime as a function. And so as we slide along our x values, you can see that the slopes of the tangent lines to our function g are getting, they're going from negative, they're all negative, but they're getting closer and closer and closer to 0. And you can see that's exactly what the behavior of the derivative is doing. It's always negative, on it, at least on this piece that we're looking at. It's always negative, and it's getting closer and closer and closer to 0. You can watch that play out. And again, be very clear, the y values for the derivative at a point, at the same x point, correspond to the slope of the tangent line here. So the slope of this, the slope of the original function at this x value, 0.29, is negative 0.57. So if we were to slide this over, the y value is 0.31, but the slope of the tangent line agrees with the y value down here. It's negative 0.57. So I'll just go ahead and slide that bar across, and you can watch what's happening as it goes along. All right, very good. Let's go on to a little bit more information in the next video.